Alright, hello and welcome to a new week. In between hard lecture slides is a nice simple one for once. So we're going to talk about files and streams for the next 2 lectures, and this is going to be a relative breeze to the stuff that we've been learning recently. Okay, so look forward to that. And before we get started, let's talk about the next midterm, because it is week 10, and the next midterm will be during week 12, like I promised. Okay, so let us go there. And there is, sorry, my cat is playing with a ball with a bell on it. I'm sure you can hear that. So there is a midterm 2 module that I'm going to make available. So it'll have an info page, a review page, extra credit, and the actual midterm itself. The first couple pages that I'm going to release are definitely the info page and the extra credit page. So let's go over those. So the midterm 2, it's going to be available between the 8th and the 9th of April. Okay, the same times as the last midterm. So it's going to be a Thursday and a Friday, 2:30 to 5:30. 2:30 on the 8th, which is the Thursday, to 5:30 on the 9th, which is the Friday. Okay, and so everything else is the same. Probably what you care about hearing are the topics involved, so lectures up through week 11, but I will try my best to not ask many questions about recursion, okay, because that'll be the next topic. I'll try and save those for the final. So files, this thing that I'm about to teach you now, that is the last major topic that I'll be testing you on, okay? And then we have, of course, the Zybook readings and your Zylabs through those chapters, and labs 4 through 8. Okay, so those are places that I will be potentially taking topics from. And here's a nice little list if you want to look into that. Okay, that is the idea. One thing that you will be reading about in your textbook that I will not be testing you on is the intersection of pointer and classes concepts that involve both of those. So linked lists, I know we talked about a tiny bit. I promised before, and I'm promising again now, I'm not going to test you on that. And also destructors. Those one that will not be on the midterm. Okay, that's a CSCI 41 topic, and so at least you're getting some good practice for that. And yeah, the format's the same. Prepared to paste code into a text box, and as usual, you can look at all the notes that you have, but you can't interact with humans. Okay, so that is the next midterm. So please yell at me if you have any questions about that. And then there's also the extra credit assignment. It's exactly the same as the first one. It's just instead of make midterm 1 review materials, make midterm 2 review materials. Everything else applies in the same way that it did before. And let me know if you have any questions about that. I'd be happy to give you some pointers if you're wondering what you might want to talk about. Okay, so back to the slides. Let's confirm we're still recording. It's time for files. Are you ready? Okay, this is not going to be bad at all. This is a nice, easy set of slides, relatively at least. So the first thing I want to talk about is Fstream. Okay, this is a weird name because as programmers we like to make words shorter. Okay, we like to abbreviate. So let's talk about what we can do right now in terms of giving information back to the user, outputting things. Okay, so we care about outputting and inputting for this set of slides. So right now we can use cout, we can say cout something, cout 42, and it just magically appears on the user's screen. Voila, there's the 42. Bam. That's nice, but wouldn't it also be nice if there were more options? And here is another. So there's something called Fstream, that stands for Output File Stream, and it is a specific type in C++. It's not in the same as cout. Cout is like a variable. Fstream is a type, so you can declare a variable of type Fstream, just like you can declare a variable of type int, and it's a type that writes to a file. So it knows somehow that it's got a file inside of it, and it knows that when you send it information, that information gets written to the file. Okay, so the idea is you create an Fstream object, and you give it a file, and it's going to write to that file for you whenever you give it things. Okay, so that's really all there is to it. Ifstream, it lives in the header called Fstream, okay? So you're going to be including Fstream if you want to use it. So you'll say number sign include Fstream. And yeah, it stands for output file stream. And the beauty of it is once you have an Ifstream object, so you say Ifstream OFS or something, and then you give it a file, ... I'll show you how to do that in a second. You can say OFS 42, and it will write the characters 42 to whatever file it has open. Okay? That is the beauty of Ifstream. Are you ready? So, yeah, here we go. Let us write the numbers 1 to 10 to a file. Okay, so like, I don't know, 1 to 10.txt is going to hold the numbers 1, 2, 3, 4, all the way down to 10. That's what we would like to do right now. Okay, so we're going to include the Fstream header first of all, and we'll go from there. Okay, so I'm in the Lecture 19 folder. Let's do, let's edit a file called, I don't know, 1 to 10.cpp. So we're going to include Fstream, and now let me show you how to use Fstream. And if you're ever wondering, there's always the wonderful, wonderful documentation page, okay? And I encourage you to use that. So I've opened it over here. You can always just search for C++ Fstream like I did to find it. And inside of this header, it has all the types that are involved, and we have the Ifstream class right here. So we can click on it, and we can see how to use it. Probably the best place to start is to look at the constructor. Like how do you make an Ifstream? What do you do with it? And there's a nice little example usually. Okay, so the idea is you can give it a file. You can give it a file, and it will start outputting to the file. Okay, so the steps that you usually take are you make an Ifstream object, you declare it. So that you have an Ifstream object that is ready to write to a file, and then you open the file name that you want to write to. You can use the constructor for this. Just like the example on the page was showing. Be like, okay, make an OFS with test.txt, or you can say .open, wherever that is. Dun dun dun. Oh, I think it's because it's part of Ostream. Most likely, it's going to be one of these, isn't it? Or, you know, it might be here. Let's search. .open. Open mode. There it is. I couldn't find it. .open, and that opens a file for writing. Okay. You don't have to give the second parameter. The first parameter is very important. It's the name of the file that you want to open. Okay. So you can say ofs.open, and then you give the name of the file. Okay. And you don't have to worry about the second parameter for right now. And or with the .open method. And then we're going to write to the file, pretending like it was cout. So you can use like those two arrows. Those just work. It's beautiful. And then finally, once you're done writing to the file, you close it. It's a very good practice to close the file after you're done writing to it. Okay? So the opposite of open is close the file. Okay, close the file, and you can read all this fun information about it. It does some important things. So yeah, ofs.close once you're done. Okay, so this is our process. Essentially, we're going to change the normal way that we print from 1 to 10 to the screen, like, oh, we want to start at 1, don't we? And go up until 10, right? Yeah. And then I++. And so this is how we print, right? See how I, new line. We're going to change this very, very easily to a much simpler, or not simpler, it's just this simple, an equivalent way of writing to a file. So G++ that 1 to 10, 1 to 10, There we go. And so this is printing to the screen. We're going to change this to print to a file now. Okay, so we're going to follow all these steps. We're going to make an Ifstream object. For lack of a better variable name, I usually just say OFS, output file stream. And then we say ofs.open. Okay, and we give it the file that we want to start writing to. So let's just call it, I don't know, 1 to 10.txt. Okay. So what this does is it hooks up OFS to this file that it's about to make, and it opens it for writing. Okay, not reading, just writing right now. And then we can give information to OFS. We can start writing to the file by replacing the cout with just OFS. So we can give information, give stuff to OFS, just like we would for cout. It's very similar. It's made in the same vein. And then we're done writing. My cat is going crazy right now. I apologize. Then once we're done writing, we close the file. So you say ofs.close, and all is well. Okay, so it's this sequence. You make the Ifstream object because you need to use it to write. You open the file using it, and then you start writing. And then finally, once you're done, you close the file. That is the steps. Those are the steps you should always take when you're writing to files. Okay, are you ready? So, ./1 to 10 this time. I'm going to hit enter. And it's not going to output to the screen because I'm not using cout. I changed it to OFS. What happened was a new file got made, 1 to 10.txt. That didn't exist before. And if we look at it, vim 1 to 10.txt, it has 1 through 10 in it. Isn't that beautiful? You can also say cat 1 to 10.txt, and that prints it to the screen. It like reads it and prints it at the same time. That's a fun little command to do that. So yeah, it made this file with 1 to 10 and some new lines. Isn't that cool? So that's your other way of getting output. So that was my short little example. And I want to show you that you can be lazy on closing files. Or at least I wanted to tell you that. It's a very good idea to always close a file. .close. Use that. As long as you can remember it. But there is one catch where it's not really necessary. The file will be closed for you at the end of the scope. So when the variable OFS goes away, the end of the scope is usually the closing brace, the nearest closing brace. So, for example, once main is over, OFS gets deleted, and so whatever files were open in OFS are going away, no matter what. So that's the idea. So you don't technically have to use close here, but it's very, very good practice. Okay, so I'll just leave you with that comment. That's the idea. So I want to talk about appending now because there are some interesting things going on right now. So if I rerun this program, this 1 to 10 program, watch what happens. Here's my file, 1 to 10.txt, rerun this program. It does nothing different. It outputs to the file, 1 to 10.txt, and it overwrites everything. So 1 to 10 used to be there, 1 to 10 is getting written back. If the file didn't exist, if I remove it, now it's gone. It's as if, and I run it, it's as if nothing happened, okay? Just like the first time. I can rerun this program as many times as I want. It's going to keep overwriting the file with the same information, okay? So, oops. We would like to sometimes not replace everything, okay? Because right now everything is getting replaced. Sometimes we want to keep what's there and then add it to the end of the file. So maybe we want to keep whatever was here and then 1 through 10 Maybe we want to put 11 right after, and our program just works on adding the 11 part. This is called appending, okay? Putting at the end of an existing file. It's called appending. And the way that we do this is we open in a special mode, we say, okay? We open the file in the append mode, okay? So we say .open, give it the file name, and then we also give it this, iOS base : app. Okay? That is the idea. We give it that. Let me draw that better. This means open the file name that's called this in append mode. Okay? That's the secret second parameter. Okay, so let me show you that. If we go to the .open, you can see that the default one, that's why we don't have to give it, the default opening method is to just output and overwrite. Okay? That is very nice. Sometimes we want to, though, do app instead. Okay? That is what we want. Okay, so yeah, let me just show you that, and that'll be that. Okay, let's go here. Let's do append. Let's make a new file called append11.cvv or something. I don't know. So this file is going to append the number 11 to this file name. So we're going to open it, but we're going to open it for appending. Let's change this to iOS base append app. So now we're opening it for appending, and we can give it 11. Yeah, why not? And then we'll close it. So, because we're opening this in a special mode, it's going to get appended to. The file is going to have changed a little bit. So I run it, there's no output again, but if I look at the file that we have been working on, 11 got added. You see that? That's quite nice. It didn't touch what was there, it just added to the end. And now, try and guess what's going to happen when I run it again. Bam. What do you think the file looks like now? Now it's got 2 11s. Yeah. Just keeps on appending one new thing. Now it's got 3 11s. Isn't that beautiful? So that's appending to a file. It's quite nice to do. We often want to keep what was there and just add to what's there. Okay, so now I want to talk about a weird concept called inheritance, which is again a topic for CSCI 41, but it's good for you to hear about it a little bit now. Okay, so I want to tell you why Fstreams, like, they have this operator, they kind of behave like cout. Why is that? So cout, the type of cout, we've never talked about it. Let's talk about it now. Let's go to Ifstream. Let's go to cout. Cout's a variable, by the way. It's of a certain type. The type of cout is called Ostream. Can you believe that? The type of cout is Ostream. Okay? So Ostream is just another type, not a big deal, and somebody has declared, like the standard library people, they made a special global variable called Ostream cout for you. That's what they did. Okay? And that's what you get when you include Ifstream. Isn't that beautiful? And then Fstream, or Ofstream, sorry. Ofstream is also an Ostream. Okay? So cout has all the Ostream properties, and Ofstreams also have all the Ostream properties. Ostream stands for output stream. Ofstream stands for output file stream. So it's like a specialized version. Fstream is a specialized version of Ostream. And so we get to the concept called inheritance. Ofstream inherits from Ostream, and so it takes most of its qualities. In addition to that little operation, okay, that operator less than, it exists at the Ostream level. And so that's why we get it in both, okay? Ostream's the more basic type, and because they are related by those types, they work similarly, they have the same operators implemented. Okay? That's the beauty of it. So you can say cout arrow arrow, or you can say Ofstream OFS arrow arrow. They're getting it from the Ostream class. Okay, so let me show you these diagrams that now should make a bit more sense. If we go to the Ofstream type, we see this, and I have made my my web browser have dark pages all the time. Let me get rid of that for a second and look at the arrows. Ofstream comes from, it inherits from Ostream, which inherits from iOS, which inherits from iOS base. It's stealing all of these things from these places. Ostream, this is what an Ostream is, okay? It has this operator. That's where it is defined. It has all these special files, or not these files, all these special functions, all these special methods that you get for free in Ofstream because Ofstream is an Ostream. That's the beauty of it, okay? And so that's why you get all the same stuff in Cout, because it's an Ostream. So it has all the Ostream stuff like that operation, okay? That is all. That is my rant, okay? So that's why they are the same. That's why they work similarly, because their types are related. They inherit from one another. There's some nice little metaphors going on in computer science. That's another one of them. All right, so now let me show you a fun thing. Because they are the same type, Cout's an Ostream, Ofstream is an Ostream, I can make a function that takes an Ostream. It's already bold, let me highlight that with an underline. I can make a function that takes an Ostream and write to it. Send it to whatever. I can give it Cout, or I can give it a file just as easily. So I can make this function, void write 1 to 10, and I can give it an Ostream reference, because why not? And I can write to this Ostream, and I could pass along just as easily. I could pass along a file, or I could pass along Cout itself, because they're both Ostreams. They both inherit, and so I can treat them like Ostreams. That's the beauty of everything going on here. These types are all interrelated. All right. So inside of the function, I can say OS and give it the little arrows, because I know that Ostream has that implemented. Ostream has this method, this operator implemented on it. Okay, and it will write to whatever kind of output thing it is. All right. If it's a file, it'll write to the file. If it's Cout, it'll write to the screen. Okay. Dun dun dun. So I think I meant to say, I think I meant to copy and then get rid of this. There we go. So this should all make sense now. All right, so if I run this, it's going to write to the file. If I run this, it's going to write to the screen. And it will work just the same. Let's do that. Let's make a file called, I don't know, Ostreams. Or just ostream.cpp maybe. Are you ready? So let's take this original file, because that has most of the implementation that we need. So we're going to package all this stuff up into another method, or sorry, a function. So void write, what do we want to call it? 1 to 10. And we'll take an Ostream, just a plain Ostream, not an Ofstream, just an Ostream. OS. And then I will paste all this, and we're writing to OS itself. Yeah, that's nice. That's a little function. And so now watch me do this. Isn't this nice? Because I can say write 1 to 10 and give it OFS, of course, and it will take this OFS and it will become OS, and it will write to OS, and it will write to this file. I don't know. Let's call it the Ostream version, because why not? Bam. So I ran it, and it took this, gave it OFS to this, and it's going to write 1 to 10 to this file then. And it should have, there it is, cat 1 to 10 dash Ostream, and it's got 1 to 10 in it, no big deal. But this is where it gets cool. I can just as easily, because the types are the same, Cout is an Ostream, OFS is an Ostream secretly, I can give Cout to this function as well. And in addition to writing to the file, it will write to, oh no, something is horribly wrong. I don't know why. In addition to writing to the file, it's going to write to cout. And let's see why it's complaining. No, it's not really complaining. I don't know why it's unhappy right now. Yeah, who knows? Maybe I have to close this. I did something weird. Now it's happy again, I think. There we go. So, recompile, rerun. What's going to happen is, it's going to both write to the file. So let me get rid of it, actually. It's not there right now. And now let's run it. So it's going to write to the file, and it's also going to write to cout, the same method, or sorry, the same function. It's going to do the same thing. So it wrote to cout just as easily as it wrote to that file. Life is good. Okay, so the types are the same, they inherit from each other. Okay, that was a long-winded rant again, but it's very important to understand this, at least at a very basic level for this class. Okay, types are interrelated. It's a beautiful, beautiful thing. Okay, so we've spent a lot of time writing files. We should maybe talk about reading them too, right? Cover all our bases. So the analog of Ofstream for reading from files is Ifstream for input file stream. That makes sense, doesn't it? So this is another alternative for getting input from the user. Okay, we want to get input from the user, and the methods that we have so far are using cin or getLine with cin, or using like command line arguments to get information from the terminal when the user runs this program on the terminal. Okay, so yeah, either like the program's running and you're getting information from the user, or the program's about to run, the user's typing stuff on the terminal in addition to the program name, and then they press enter and we get that input through the command line arguments. So the third option now is to read from a file. Okay, so again, because we have types that are interrelated, these work very similarly to cin. Okay, you still have this arrow in the other direction operation because cin is an Ifstream. Isn't that beautiful? An Ifstream is an Ifstream. It's all so wonderful. Okay, so that's what Ifstream is all about. Yeah, that is the idea. So yeah, let me give you an example just to prove. And I do want you to keep in mind that they're both Ifstreams now, so that's why we can use this operator. Okay, so here's what we're going to do. Here's my example for us. We are going to read some numbers from a file. Oh man, I should have never installed this thing. It's annoying. No, go away. Okay, so we're going to read 5 ints inside a file. So the first 5 ints. So maybe we can read the 1 to 10.txt. We can just read the first 5 ints that we see in it, and then we're going to sum them. Okay, and we're going to assume that the file has white space separated numbers. So they're either all on the same line, these 5 numbers, or they're all on different lines, or maybe there's like some combination of those with tabs in between. No big deal, as long as they're separated by some form of white space. This operator is going to work, just like it does for cin. Okay, so let us make this happen. So instead of Ofstream, let's go back to Fstream and go to Ifstream, and you can see the constructor. Again, my cat is insane right now. Sorry about that. So again, you just give it a file. You can give it a file in the constructor, and maybe I should do it this way instead. But otherwise, you can use .open again. Okay, and then you can get stuff from the IFS. Okay, all right. So here we go. ifstream.cpp. So we're going to include Fstream again because both Ofstream and Ifstream live in Fstream. Okay, and then let us declare things. Let us declare things. All right. So we're going to read 5 ints inside the given file. So we need an Fstream. We need an Ifstream to work with. And I usually call it IFS, okay? And we could say ifs.open, the file that we want to read, like, I don't know, 1210.txt. We could do it this way, or we could do it in the constructor, okay? You can like open and declare in one fell swoop with the constructor parameter. It takes what you want to open. Okay, so instead of using open, we can give what we want. We can give the file name to the constructor, and this works for Ifstream as well. Okay, 1to10.txt. And so now it's open. We don't need this anymore. And now we can read from it. So we're going to read 5 numbers. So let's do that. Let's see why it's unhappy. I'm really not sure. Maybe my Vim is just unhappy today. Yeah, it's doing just fine. So we have that, and now let's read 5 things. And sum them. Okay, so let's keep track of the sum. And now let's just in a loop, int I equals 0, I is less than 5, I plus plus 5 times. We're going to go and read from IFS. So int, I don't know, n or something, and we can read from IFS into n. Read one white space separated, hyphen goes there, int. Okay, so we got one int from the file, not from cin. It looks very similar though. And then we're going to add to the sum. Okay, and then finally we can see out the sum if we wanted to. We could write it to a file even. Sum and a new line. Why not? Okay. So yeah, my Vim is very unhappy. It could be because I have called it ifstream.cpp. It might be very unhappy because of that, but I'm pretty sure what I'm doing is fine. Yeah, it compiles. So, are you ready? So we told it to read from this file. It's going to read a bunch of ints now, because we use IFS just like we can use cin. We can even use getLine as well, in addition to these this input operator. And then we add all the summed n's that we get, all 5 of them, and we sum them together. So, without any further ado, we're going to run this program, which is going to read 1to10.txt, which has these lines first, and apparently it's got 5, 10, and 5 more. It's got 15 things. Those are the first 5 numbers, 1 through 5, sum to 15. Isn't that so nice? So that is, yeah, that is my example of iStreams, my first example for you. And now I want to talk about reading from a file inside of a loop. So I have a lot to say. Sorry about that. So I showed you this secretly in that count words example from the lab, one of your labs. So I did something like while cin arrow word or something, and I used like getting input as a condition of a loop. Okay, so I'm going to talk about this now. Cin is an iStream, Ifstream is an iStream, so let's talk about reading from some iStream as the condition of a loop, and also let's talk about the .eof method, which exists on all files, even Ostreams, I believe. So here is my rant again. It would be very nice to be able to read the entire contents of a file, to go from start to finish, but we have no clue once we start reading where the file ends. We don't know when to stop reading. Like the user can't just give us, okay, this is how many characters are in the file, because maybe they don't know, or maybe the file gets changed a little bit as we write, depending on its contents. So we have no clue, usually, when to stop reading with our current knowledge. Though, there is a solution, okay? The solution is an Ifstream object, actually an Ifstream object, can be converted to a Boolean value. This is the trick, okay? And so it makes sense to say if IFS, and let me put that in like a different font so that you see that that is code. It makes sense to say this, if IFS is true. Like, check it for truthness, even though it's like a file. It's weird. But it knows how to convert it. C++ knows how to convert it to a Boolean value, to a true or false. And that value, that Boolean value, it represents whether the file object is, quote, okay, okay? If it's true, the file is okay to still be read from, okay? That is the idea. So in Ifstream, it stops being true the second you've reached, or tried to read past even, the end of the file, okay? And this magical concept is the next thing we'll talk about, the end of the file, okay? So the second you start reading past that, or you get to the end, the Ifstream becomes false. So if IFS, it becomes false. It doesn't execute the if statement. We want to check for this. This is how you do it. If you want to just check by yourself, you can say if ifs.eof is true. Okay, so let's go there. Ifstream, it has an EOF method. Actually, yeah, EOF is fine here. That is specific to files, though. So EOF returns true if the weird state flag is set for the stream. All that means is the end of the file has been reached. Okay, we've gotten to the end of the file. It returns back true or false. It's a Boolean value. Okay, so you can use that by yourself if you'd like to check for whether or not you have got to the end of the file. Okay, it will return true or false. So yeah, the next trick for why this original thing worked at all is that we can get input. And now my cat is eating my headphones, so I will have to pause the video and fix that. Okay, crisis averted. Where was I? So, this is why this whole thing works now. Why we can use, like, this entire statement and still get a Boolean value out of it. Why does that work? Well, here's the trick. When you use these arrow operations, when you use this operator on IFS, it gives back a value. It's technically a function. It's a method on IFS, right? This is just operator arrow arrow greater than. It works in a special way, and it has a return value. It actually returns the IFS again. It evaluates to IFS. So this gets replaced when you say, like, while IFS get a thing, this gets replaced. It returns back just IFS. It evaluates to IFS, so it's as if you said while IFS, and then you can get the Boolean value because it converts itself. So that is why we can say, okay, while this is true, we know that we've read something correctly. The read operation has succeeded, okay? And the second it stops, the second it gets past the end of the file, we know that this is false. And so we can set this as the condition of our while loop to read all the valid lines or valid elements, valid values, let's just say, out of an Ifstream, out of a file. Are you ready to have an example of this? That'll be the last example for the day. So this is beautiful. This is beautiful. So let's sum the entire file. Let's do that example. Dun dun dun. I don't know. Let's put it over here. Example. Let's sum the numbers, all the numbers in a file. Okay? So instead of just the first 5, let's do all of them, because we know how now. Sum all numbers.cpp. That's my best idea of a file name. So we can open the file, and now we can read in a loop. That's the beauty of it. So int n, we can say this. while ifs get a number n. So continue, or while ifs successfully gets a number n. Okay? So we can say that we now have it inside of here. N got set to a valid value because we know that this succeeded. It gave back true. That's where we're going with this. And so we can just say sum plus equals n because we got the n as part of the condition, which is weird, I know, but that's how you do it. So we add to our sum, and now if I rerun this, compile this, and then run it on the file that we have already, 110.txt. Again, it's underlining for some weird reason. I'm going to have to check on my Vim first to see why it's doing this. Bam. So if I run this, it'll get everything in this file, which apparently sums to 88. Isn't that nice? So it knows when to stop. It knows when it's past the end because, like, ifs.eof is going to be true because we know once we get past the end of the file. Okay, and it won't try to read past the end of the file. That's what it's doing. Okay, it's like true. True, we have read past the end of the file. It doesn't like the character E, I guess. Who knows? All right. Doesn't like the character U. So odd. Who knows? Who knows why it's doing this? Okay. So, yeah. Sum is 88. And that is how you can read inside of a loop. It knows where to stop. All right? So that is my example for you. That is reading files. We're going to come back in the next lecture, and I have some fun examples for you there, and we'll finish these slides. So I will see you then.